Okay, so now we're going to reverse course here. All right, we've learned how to graph in point slope form, and now let's go ahead and try to find the equation of a line. So given data, what equation fits the data? So in the first one, we're going to try to find the line, right, with a slope of 2/5 and a solution point of 8,3. Now this is a little bit different than the 3.6 because in that case we needed the y-intercept. I don't have the y-intercept. What I have is a point. So the form we want to use here, right, is this more useful form for this situation: y minus y1 equals m times x minus x1. So if I can find my slope, if I can find my fixed point, I plug them in like we do any formula and we're done. So I'm already given the slope, right? There's 2/5, and there's my x1 and my y1. I'm given a fixed solution point. So all I need to do is come over to my equation and start replacing things. So y1 is 3, the slope is 2/5, and x1 is 8. And so there would be the equation of that line that is represented by that data that's given. We're done. Move on, next question. The textbook, or even in a quiz, I might ask you to rewrite in slope-intercept form. So we would just solve for y in that case. But for now, let's just focus on, I'm asking for an equation of a line, I'm asking for it. And you gave me one. You gave me the point slope form of it, and that's good enough. In the next one, we got a picture of a line. So what equation, right? Find the line that's in this picture. What's the equation of it? And again, notice I can see a y-intercept, but it's kind of hard to know exactly what that y-intercept is. But I'm given 4 data points. So again, remember the solution point I need is any one. So if you want to use -1, 3, you can. If you want to use 4, 1, you can. If you want to use, what is that, 4, 5, 6, 7, 8, 9. This looks like 9, -1, you can. It doesn't matter which data point you use. You can use whatever you want. I'm going to choose to use that one. All right, so there's my x1 and my y1. What's missing is our slope. Right? So how do we find slope? Well, maybe we just start moving. If I start moving, it looks like my change in y is -2 because I'm going down. 1, 2, 3. And it looks like my change in x is 5. So it looks like my slope, being the change in y over the change in x, is -2/5. So I have a slope, I have a point. So what's the equation of this line? We'll just plug in what we know. Right, so we got y minus 1 equals -2/5 x minus 4. So there would be my equation of the line for that one. All right, be careful here because your friends, if you're looking on Canvas, you might see, right, if you have a friend who used this point, right, if they use that as x1, y1, then the equation would have been y minus 3 equals -2/5 x minus a -1. And if we clean that up, right, if we subtract -1, that's the same thing as saying x plus 1. So this equation is just as right as that equation. We just use a different data point. And of course, if we converted these to both to y equals mx plus b, they'd be the same thing. And of course, if you had a third friend, they could probably even use that data point, and a fourth friend can use that one. So any data point we'll use, just plug it into the formula and you're finished. So there's 2 examples for that one. Last one, this time the line we're trying to find, the equation is given in a table. And so unfortunately, if we look at the points, we notice that none of them are a y-intercept. So we're going to definitely be using y minus y1, x minus x1. We're going to be using our point slope. Which of these points did I use? As I demonstrated over here, it doesn't matter. Pick one and use it. So how about I just use that point right there? So there's my x1 and my y1. So we've got that. What about my slope? Well, we need to find it. Again, if you kind of look at the table, it looks like the x's, right, change in x looks like it's 3. And it looks like the change in y is 4, giving us a slope of 4/3. If you want to use the formula, go ahead and do that, right? So if this is x1 and y1, how about we use this as x2 and y2? So the formula, I would have 6 minus 2, 4 minus 1. My slope is 4/3. So there's my slope, and there's my point. So what's my equation? Y minus 2 equals 4/3 x minus 1. Okay, of course, if you have a friend who used that data point, their equation will look like y minus 10 equals 4/3 x minus 7. And they would be just as right as you are. All right, so, and then again, we could do one with that one or that one. Very, very flexible form. Just make sure you find your slope right, and make sure you plug in your data point right, and we can have several different looking equations for the line, which probably makes the slope-intercept form a little nicer, right? Because there's only one y-intercept, so there's only one slope-intercept, and that's probably why it's used a little bit more often. But that's how we do things with our new point-slope form. All right, so more examples coming later.